Hi friends, now we will consider a simple problem on source free RC circuit. And you consider this problem. Here you have a 12 ohm resistor and you have 6 ohm resistor. The voltage across the 6 ohm resistor is Vx, and then is an 8 ohm resistor. The current that is flowing through this 8 ohm resistor is I naught, and you have a capacitor, its value is 1 by 3 farads, and the voltage across the capacitor is Vc. So in this problem the initial condition is given. Initial condition is Vc of 0 equal to 60 volts. That means initially the voltage across the capacitor is 60 volts, and what we need to find is we need to find Vc, Vx and I naught for t greater than 0. What is the meaning of it is, for t less than 0, uh, there may be the initial condition, that is Vc of 0 equal to 60 volts or at t equal to 0, and here there is no source, no voltage source is there, but because of the initial conditions, this circuit you can treat it as source free RC circuit. Now here our aim is we need to reduce this circuit in the form of our general circuit. What is the general circuit is that I explained during the derivation. So I can consider this as R equivalent, and that means whatever the three resistors I have, that I will reduce in the form of one resistor by applying Thevenin's theorem. So I call it as R equivalent. The other one, as it is, I can call it as the capacitor. The voltage across the capacitor is Vc, and 1 by 3 farads. Even in the derivation, instead of writing this Vc, that we have written Vc here. So our aim will be to find R equivalent. So what we said how to find the R equivalent is, you open the capacitor and at the terminals of the capacitor you find the Thevenin equivalent resistance. So this circuit, if you consider, we'll be modifying this circuit as, for finding RTH, we open the capacitor, and by looking back into the circuit we'll be finding the RTH, which is nothing but R equivalent. And if you consider from this circuit, you have RTH can be found out. This 12 ohms and 6 ohms are in parallel, so 12 parallel 6, which will be in series with 8. So this 12 parallel 6 will yield you, I think, 12 into 6 by 12 plus 6, and whole you can add to 8. So the first one you'll be getting 12 into 6, 72 by 18, which is 4. 4 plus 8, you'll be getting 12 ohms. R equivalent or RTH, which we'll be calling, you can call it, you obtained it as 12 ohms. Now the time constant you can find it as R equivalent into C. R equivalent is 12 ohms and C is 1 by 3 farads. So tau you can call it as 4 seconds. Now the expression Vc or Vc of t, we have written it as V naught e power minus t by tau. V naught is already given in the problem as 60 volts. 60 into e power minus t by 4 volts. So this is the answer we got. Vc equal to 60 into e power minus t by 4 volts. So here, if you can rub it off, can write Vc equal to 60 into e power minus t by 4 volts. This you can further write it as 60 into e power 0.25 t volts, that is Vc. Next you need to find Vx. So Vx is the voltage across the 6 ohms resistor. So to find this one, how to consider it is, this 12 ohms and 6 ohms are in parallel. So if you consider this parallel combination, that is 12 parallel 6 by 12 parallel 6 plus you can consider this 8 ohms, because 12 parallel 6 in series with 8, this entire thing forms a potential divider, and you can consider this one as 12 parallel 6 by 12 parallel 6 plus 8 into Vc, because if you again refer to the circuit at this terminal or at this node, the voltage is Vc. So how we have written this one is, we need to find the voltage across the 6 ohms, which is the voltage at this node, which is same as the voltage at this node. So we have written it as 12 parallel 6, that is 12 parallel 6 by 12 parallel 6 plus the series resistor 8 ohms into the node voltage Vc. Suppose 12 parallel 6 you already did it as 4, that is 4 by 4 plus 8 into Vc. Vc is 60 e power minus 0.25 t volts. Suppose this 4 by 12, that is 3, 60 divided by 3 is 20 e power minus 0.25 t volts. So this is the voltage that is asked in the problem, that is across 6 ohms. Next we need to find I naught. So this I naught is the current that is flowing through this 8 ohms. So here what I do is, to find I naught. To find this I naught, if you refer to this figure, I consider this mesh. So if I write mesh equation by KVL, I can get it as minus Vx, that is minus Vx, I'm going through this like this, minus Vx plus the potential across this 8 ohms, we can write it as 8 I naught plus Vc equal to 0. You already know Vx. Vx you obtained it as 20 e power minus 0.25 t plus 8 I naught, which you need to find it out, plus Vc we got it as 60 e power minus 0.25 t equal to 0. Now here you can write 8 I naught equal to, you consider this term and this term, you can write it as minus 40 e power minus 0.25 t. So I naught is equal to minus 5 e power minus 0.25 t amperes. So this is the third one they asked in the problem. Again coming back to verify our thing, you know Vc you got it as 60 e power minus 0.25 t. Suppose you substituted t equal to 0, So VC of 0, or that one you can get it as 60 volts, which is verify. Thank you.